I'd like to welcome you to the course Advanced English for Mechanical and Electrical Engineers. My name's Chris Tidy and my own background is in mechanical engineering, but in the last few years I've developed an interest in teaching technical English as a second language. This course has been running for several years, but this year for the first time it will take place entirely online, so sadly I won't be meeting you. As a teacher, this is a source of considerable sorrow to me because the classroom sessions are always lively and productive and a good learning environment, and it's always a pleasure to see my students develop. But it also gives you an opportunity, and that means that you can organize your time more freely and you won't have any problems with courses colliding, and you'll be able to focus the course more precisely on your own engineering interests. With that, of course, comes the responsibility that you'll need to keep yourselves motivated. So I suggest that when it comes to the exercises in the course where you can pick your own topic, you can pick your own articles, you can pick your own components to describe, that kind of thing. Pick the things that really interest you. I'll start by talking a little about the structure of the course and the goals. The idea is that you'll be learning technical English in context. And that's very useful because if you learn technical English from a textbook or something like that, then you probably haven't seen the machine or understood the theory, that kind of thing. You've just learned, well, this word belongs in this gap. Now, some students find that useful. I find in mechanical and electrical engineering, though, that they are really a very small minority. Most people prefer to learn in context. Now, the structure of the course is such that every week I will be uploading an information sheet and a task, an assignment on the same topic. And in your own time, you'll be able to go through the information sheet, think about that. You can ask me questions if you want to, and that applies at any time. If you have a question, whether it's about the English language, whether it's about the structure of the course, about the assessment, just send me an email. I'll get back to you as soon as I can. So the idea is that each week during the lecture period, there will be one of these assignments to do, and the first few of those, about the first 5 of those, will be fairly general on topics like geometry, engineering materials, a little about vocabulary and grammar, sentence structure, and so on. And then as the course progresses, you'll need to think of an idea, something that you would like to build, not necessarily from the point of view of, just from the point of view of the engineer, but also from the point of view of what you'd like to see in your own life. And hopefully something that's relevant to your own subject area. So people in mechanical engineering pick something mechanical, people in electrical engineering, something electrical, and people in information engineering, obviously something relating to computers or programming. And you'll then think up some ideas, pick the best of these, and develop it as a conceptual design, something which you then can present as a report at the end of the course. Now, the way the assessment will work is that 60% of the grade will be derived from your short assignments that you turn in throughout the course, and 40% would be derived from the final report that you turn in about your idea after the end of the course. Now, because this is taking place entirely online, there will be a stronger focus in this semester on your reading and writing skills. And there'll be fewer opportunities for you to speak and listen. If that doesn't suit you, if you particularly want to work on your listening and speaking skills, then you may wish to take the course in the winter semester instead. If you don't like the idea of a purely conceptual design project and you'd like to actually build the project, come up with a concept and then see it through to actually constructing it in the workshop and testing it, then you may wish to take the international design project instead. But I would say there will be less of a focus on technical English in that project. Now, the English language itself is a little peculiar. Now, obviously you can already speak some English, but you'll probably be enrolled for a German language, a degree program, and you may be on different levels. And the first thing I'd say about English is it's a big mishmash of words and grammar from lots of different sources. Some from English, some from French, some from German, some from Latin, all together, mixed up together into a language which has a very large vocabulary but a relatively simple grammar. The result of that is that it's quite easy as a beginner, because you have this simple grammar, subject, verb, object, usually. You don't have any cases, you don't have any genders. It's quite simple to learn as a beginner, but the pronunciation and the spelling are very inconsistent. There are more exceptions than rules, and the vocabulary is huge. And very often in English, we have two words when in German you only have one. To give you an example, the difference between remember and remind. If I remember something, that means that I retrieve a piece of information from my own brain. It comes out and I can say this piece of information, I can write it down, I can use it. If I remind someone, then I'm telling someone else not to forget something. And that's an important difference. And there are more highly technical ones. In electrical engineering, there's the important difference between insulation and isolation. Insulation is what you have around a cable to retain the electric charge and prevent the electric charge from escaping and flowing away in the wrong direction. And can also apply to heat, water, sound, that kind of thing. But it's basically this material around the cable that channels the electric charge. Isolation, on the other hand, is technologies or measures that you would, say, build into an experiment or a machine to prevent external influences from interfering with the performance of the machine or with your measurements. But then it is a technology or a state or a measure and not a material. In mechanical engineering, there are also similar differences. Here you can see there are a couple of springs which are designed to isolate a machine from the ground. So perhaps the ground vibrates and you don't want your machine to shake because it has delicate instruments in it. Or perhaps the machine vibrates and you don't want the ground to shake. So you separate these two so that they don't interfere with each other. And this is a mechanical form of isolation. And you can see it's provided by two springs here. These are quite big springs. They're made out of quite thick steel, and they're quite stiff. They're quite hard to deform, quite hard to make them change length or shape. However, they're not rigid. And this is an important difference. It's a mistake that people often make in their text, the difference between stiff and rigid. This hexagon key, for example, is quite large. If I try and bend it, I can't feel it give at all. It doesn't seem to be flexible at all. There's no movement. The springs, you see, when I squeeze them, they do change shape. They do flex a bit, but it's difficult. That's stiff. If, in the context of your machine or experiment, the deformation, the elastic deformation is insignificant, it's so close to zero that it doesn't matter, then something's rigid. And you'll find that in this course, the way I usually work is surrounded by machines and components and books. And I hope that's something that you'll also be able to do at home. So look around you, look at what you've got at home that you can examine, that you can possibly take apart. Look at what books you've got. You may need to buy some more. And things that I'll get you to do using your own objects and your own text are things like describing shapes. This, for example, is an anvil for a goldsmith. It's a real anvil. It's made out of forged steel, which is then chrome plated and painted. And you can see here at this end, you've got a round cone, and at the other end, you've got a square pyramid, which you can hammer a ring over to change its shape. The bottom, you can see the shape of the bottom. You can see there are two semicircular cutouts. The feet at the end are a little broader. These are all things that you can learn to describe precisely in this course. There are other examples. One here, for example, a pair of tongues. Now, tongues are a bit like scissors. They consist of two arms. These arms are made out of a piece of round steel bar, which is then wound up into a loop to make a handle at the end. The two steel bars are then flattened so that they're square in cross section. A hole is drilled through the pair, and then they're riveted together to create a pivot. And then each arm is bent downwards at 90 degrees, and it has half a bowl, so to speak, attached to the bottom of it, roughly a quarter of a sphere and hollow. Now, small challenge here. If anyone can tell me what the original use of these tongues was, then I will give them one packet of 6 beers of their choice, or, if they prefer, a box of chocolates. First correct answer sent to my email address wins. It's also interesting to take a look at more sophisticated machines and components. You can see here there's a section through a water valve made of cast iron. You've got seals inside it. This part here is chrome plated so that the water doesn't rust it. You can see it's been sectioned here and it's been painted. You've got nuts to hold it tight, and you can look at all these individual parts and you can learn the correct vocabulary. And when you're not sure, I'd suggest take a look in a suitable book. Sometimes the internet is a good source, and sometimes the internet is not such a good source. You'll find usually in patents tend to use the right words for things, but they can have very, very complicated lawyer-like language. I'll go through a few books which may be useful to you in this course. The first book I would recommend, because this book is really good fun to read. It's not written in such a dull way as your average engineering textbook. Invention by Design by Henry Petrosky looks at the design process, at plenty of disasters and things, tells a very good story. I strongly recommend that you read this book. A general manual on design with a particular focus on ergonomics, on intuition, on how to make products that are understandable. The Design of Everyday Things by Donald Norman. If you're a mechanical engineer, you may also want to get a large manual which goes through the basics of mechanical engineering, so things like materials, manufacturing processes like casting, forging, machining, things like bolted joints, standards, all sorts of things. For mechanical engineers, a good choice is then the American Machinery's Handbook. This is the kind of thing that you can dip into in the course, especially when you're later working on your own idea, working on your own concept. For electrical engineers, I have a much older version here of the Standard Handbook for Electrical Engineers. This really is a goldmine of knowledge for electrical engineers, and there's a great deal of vocabulary that you can learn in there just by reading. So I would definitely recommend in the course of this next semester that you read as many books as you can, and that you look at as many manufactured objects as you can. Just to give you an example of the kind of thing that you may want to design later in the course, for the 40% and for the report. A lot of people like household objects, so things that they're already quite familiar with, things that maybe frustrate them, things that they'd like to see designed in a much better way. This here is a cafetière, French word you see, used in English, and it's used for making coffee. Some of the problems that can occur with cafetières, this is one that I bought in Russia, in St. Petersburg, and you can see here that the piston has become a little deformed here, and this can start to leak, the coffee grinds can get past, and you end up with what tastes like a mouth of soil when you drink your coffee. Sometimes it can block up here, where there are the slots, to let the coffee grinds through. Sometimes they don't pour very well, so when you try to pour it, if you try to pour slowly, then the coffee will come down the side here. And here, the handle, this one is actually quite good, but sometimes you can burn your handle, the handle can break off, that kind of thing. This is probably a little simple for a project within this course, unless you want to do a lot of work on, say, styling and the vocabulary that would be associated with styling, or if you want to look at in detail about customer needs, about the market, about manufacturing processes. If you want to actually talk about mechanisms and things like that, then it's a bit too simple, but really, as I've said, it's up to you to pick your own idea to suit your own learning needs. If you have a need for a dictionary, I'd recommend for English-German dictionaries the Langenscheidt series. This is a chemistry dictionary. There are also mechanical engineering, electrical engineering, physics, and so on. These have usually for each technical term quite a wide variety of terms that are explained very well, so explained in considerable detail. And for the more difficult words, I would definitely say these are better than your average online dictionary. Now, as I mentioned, there is a challenge here that you need to take the responsibility for your own learning and make sure that you stay motivated. My advice here would really be pursue what interests you. And I'm not going to mark something down if you say write a report on the chemical engineering behind chocolate making. As long as it's written in a well-structured way and the vocabulary is correct, then you'll get a good mark for it. The same would go for, say, sport-related projects, say skateboards, aerodynamics of a golf ball, that kind of thing. So, I hope you enjoy the course. I hope you have a great deal of fun, and I look forward to working with you. Thank you.